Hi guys, so today I'm going to show you how to create this fish game inside of Python. It's actually quite popular, or quite old also. You start off as a tiny little fish, and you gotta eat fish that are smaller than you to start growing, until you can eventually eat the bigger fish. So if you are too tiny, you decrease in size, and if you're way too tiny, it's game over. So that's the game. We're going to start off by using Pygame, which is probably why you clicked on the video in the first place. But we're going to import Pygame, we're going to import the OS library, and we're going to import random. So the first thing we're going to do is kind of set up Pygame itself, initialize it. Then we're going to create up some basic setup. So for me, I just kind of want to do the font because I have that game over screen. Then we're going to create a score. Score equals 0. Now I want the width and height of the frame. We got 1200 and 950 is what I chose for the width and the height of the game over, not the game over, the whole game screen. So then I'm going to call it screen because that is a good name that I like. And we're going to say display.setMode, and this is where we can declare the width and the height that we just created there. Then I'm going to say pygame.display.setCaption, and we'll call this game Fish Eater. And that's the basic setup. We are going to have to create a game loop, so it's going to constantly kind of run through everything. So we'll say game loop, and we'll say while running, and we'll have a declaration here. So this is where we're going to create a bunch of variables globally. So this is where we'll say running equals true, which is should we have the game running or when to close the game. Lost is if it's game over. So at the beginning of the game you did not lose, so it should be false. Frames per second, set that to about 60. 60 is always pretty good to do, frames per second. Then we'll have a clock. Pygame.time.clock does it for us. And for right now, that's where we're going to leave it at. We will add more to it later, just so I don't overwhelm everybody with a bunch of stuff. You can see how it all plays out. Makes more sense to me. So inside our game loop, we want to call that clock that we just made. We do .tick, so it's essentially going to go per our frame rate, right? Every time the clock goes, the frame rate should be running as well. And I think for right now, if we run this, we get a window. There we go. Of course, we forgot to code it to exit on close, so it's gonna force close, say it's not responding, there's nothing going on, it's gonna give us a little break, and that is okay. But we can fix this by essentially going into our game loop and checking if the user has actually clicked the game over, not the game over, the X button. So I already have a fish image I have an images folder. Where is it? Assets. I have assets, and in my fish eater, this is where I have some images that I'm using. So that's what I'll be using for this game. And order to get an image in here, you can just drag it into, well, whatever editor. I'm using PyCharm, so if I had something like here, I literally can just drag it over and it throws it in there. So if you find an image like on Google Images or something, you could just straight up drag it into your editor and it's all good to go. So as I was saying with the whole click X button, so we can say close on click, right? So what you can do here is you can use a for loop. So you say for event or whatever you want in pygame.event.get, which is essentially going to check any event. Essentially is like, you know, a user input of some sort. So then you can say if event dot type equals pygame dot quit, then we want to literally quit. So now if we run this, we don't have that problem and we can just close it. Boom. Pretty simple there. So let's go all the way to the top of our code because I always think it's more organized at the top, and I'm gonna load up some images. For the moment, I'm probably just gonna load 2 right now. We'll do their player image equals pygame dot image dot load, and this is where I say I use my OS library so I can join the path of assets slash fish eater, and then I can tell it the file name to get, which I had named this player fish. It's a PNG file. Then I also want to use a background image, so I'm gonna load that in as well, and I'm gonna call that BG for background, but essentially the same thing. Oh, let me plug this in. Hello. Player.image.load, and essentially it's in the same pass for me. So assets slash fish eater, and I probably called it underwater.png. Perfect. Now because this is a background, we're actually going to do this a little bit differently. So I wrote image.load, but because I want to do this a little bit differently. I want to keep this part, but I want to scale it. So we're going to say pygame.transform.scale the entire image we're loading from my path. And then I want to throw parentheses. So transform.scale pygame.image.load, and this is where we say os.path.join, and then we're going to give it the size of our frame. I put a parenthesis and it didn't want to create one. Alright, for the width and the height of our screen. And now we're going to create a class for our fish. So because we're going to have fish enemies and player fish, I'm going to create a fish class for everybody so they can inherit that. So in itself, we want to figure out where the X and Y position should be when they're created. So self dot x equals x, self dot y equals y, and self dot fish image, because again that would also be different, equals none. So we want to be able to draw them on the screen, so I'm just going to say draw, and we got to know the window to put it on. So window.belit self.fishImage, whatever was passed through when we create an instantiation of the class. And what were the x and y positions that it should be drawn onto. Then we also want to be able to get the width and the height of these things so we can compare whether or not the fish player is able to eat these things or not. So get width, I wrote self twice, get width is just going to return self dot fish image dot get width. And then we are just going to do the same thing for the height. So that's our fish class. Now I want to create a class using this for the player. So I'm going to say player, but it's going to inherit the class we just made. We didn't make it for no reason. But again, we made it so our enemy fish, when we do that, will also affect that and make our life consistent. So initialize it. Again, this guy has to get what he is inheriting, but he's also going to get some extra parameters here. So we're going to do width, height. Now because we are inheriting that fish class, we got to initialize the superclass with whatever parameters were explicitly stated. Self.fishImage is actually going to equal the player image that we created earlier. And self.height is going to equal the height passed in. Self.width is going to equal the width specified as well. And this one's weird, maybe to you or not. We're self.mask, which is pygame.mask.from surface self.fishImage. This is going to help us later when we can detect for collision. Now, right now, we can leave that the way it is and we can add some stuff later. So what I want to do is go down to declaration, and I want to maintain the player size, because when we stretch out the image, it might look super horrible if we don't maintain the original ratio of the image, so then it won't look like super warped and blurry and disgusting. Trust me, I've tested it and this is what we want to do. So we multiply it times 1, and then we do player size height, player height times 0.1. I keep typing 2. Alright, so we need that there. And then we're going to create an instantiation of the class player 300, 630. Remember, this is x and y values. And then we're going to pass in the width and the height that we just created. If you notice, there's errors, and I'm aware of that. And we're going to fix that in a second. Player speed 5, and then we can just do this for later. And then enemy start position equals. Alright, cool. So this errored out because we didn't create those variables. So I'm just going to scroll up to the top and add them because that's, again, I like to maintain organization. This is how I do it. So maintain ratio from original images. So player image width equals player. Oh wait, we didn't create player yet. Haha. Can't call a variable before you create it. That makes literally no sense. Oh, player image dot get rect dot width. And you can only imagine we're gonna do the same thing, but for the height of it, so that's that. And now we can scale our images. So we can say player image equals Pygame dot transform dot scale our player image, and then we'll say player image width times 0.1 because again it's going to get messy if we don't do this. And we put a comma and we say the same thing for the height, 0.1. And then we'll have other enemies and stuff down here as well. That's why it says images. So now we gotta scroll all the way down. So notice we haven't been able to no, we haven't been able to get anything drawn on the screen yet if you run your program, because we didn't draw it on the screen yet. So we need to create, well, we already created the ability to draw it on the screen. Tell it what screen to draw on, and it'll go in those X and Y values that are passed in when it's created, which we did here, X and Y. But we don't actually have a way to draw on the screen. So we're going to create another function, and I'm going to call it like redraw window. Redraw window. We don't need anything passed in, unnecessary. So I'm going to add background image first. We could do, screen.belit, and if you remember, I named mine. I don't know if you're going with the same names I'm going with, but that's what I did. We will draw our enemies next, but we don't even have that. So we'll draw those enemies, and then we will place player on screen by saying player.draw, and if you remember all the way to the top, we created our thing screen. So if we run this, we don't see anything, and that's because when we go to our game loop, we need to update the screen. So update screen, and we could say pygame.display.update. Now when we click the play button, we still can't see anything. That is also because we didn't call our redraw window function. So if you go over to your game loop, we need to say redraw window, and after we've done that, you also want to be able to go back in to your redraw window, and you want to say pygame.display.update, because you also need to update the screen every time you draw it. And now, when you run it, you can get your background image and you can even get your player fish. So, that's perfect. But we can't move him. That's unfortunate. So, let's move him. We're going to go and click the while loop. Let me move this console out of the way. So this is our game loop, which is also a while loop. So we want to make sure that we can move our player. So move player controls. Similarly, we need to figure out what keys are being pressed. So we'll create a list, pygame.key.getPressed. If keys pygame, notice if you do this, pygame.k, it kind of shows you all the possible keys that are on your keyboard. I would like to use right. So if you click the right key and player.get with plus player.x is less than with. I'm essentially just adding this code to ensure that you can't like go off of the screen. Player.x plus equals player speed, which we made earlier. And then player.fish image is going to equal player image. And you may ask why I'm doing that. Because I want to flip him to face the way he's moving. So like if you go left, I want the fish to face left, and then when you hit right again, it should go back to facing right. So we need to check for right, left, up, and down. So we've done right, now we gotta do left. So check if he's gone left, and oops, player.x minus player speed is greater than or equal to 0. So then player.x is plus, I meant minus equals, because we're going the opposite way now, player speed, and player.fish image equals pygame.transform.flip, or flipping player image on the horizontal axis, which if you look at this, it says flip x bool. Do we want to flip it on the x-axis? Yes, because we want to do it horizontally. Do we want to flip him upside down on the y-axis? No. We don't want him to be upside down. That's how dead fish look. We don't want our fish to look dead. And then we only have 2 more to do. So keys pygame.k will do up. So if you pressed up and the player.y position minus the player speed is greater than or equal to 0, we want to take player.y minus equal player speed. And because we're going up and down, there's no flipping. I'm not going to make him look like he's swimming up or anything. If you want to do that, you could. But I'm not going to do that here. And last but not least, if player.y plus player.getHeight is less than our frame, player.y plus equal player speed. Now we hit play. We should be able to move and see how he flips. So he faces the correct direction he needs to, and he can go up and down. Notice he can't go off the frame because we did those end conditions. He can't go off the frame, and trust it's the other way around as well. So, pretty good so far. Now, all we need to do, well, not all we need to do, we have a bunch of stuff left, technically, but we're like halfway there, I guess. I want to create an enemy because, you know, that's the whole point in the game, is to eat other fish. So, where's my class? Okay, so this is my class for my fish. Here's my class for my player. I would like to, for my player fish, we are right underneath it going to create a class for enemy fish, which is still going to inherit that original fish class. So I'm going to say image map, because technically we're going to randomize it where you can have a bunch of different fish. So yellow fish, green fish, and blue fish. Almost sounds like a Dr. Seuss book. Now it's erroring because we didn't create them yet. I know I'm kind of coding this backwards a little bit, but I know what I want to do, and then I go and do it. So it's going to take an X and Y and which image, because like I said, there's going to be 3 different ones here. Or for me, I don't know what you guys are doing since I have my own images. And we're going to call the superclass, because we're inheriting again, and remember, we're going to specify whatever it was inheriting. So the original class takes an X and Y, so we have to make sure we pass in those values because that's what the parent class is asking for. So then the image for this is going to be the image map at image, because it's going to be random. We're going to pick random ones. And then we are going to create self.mask equals Pygame.mask from surface self.fish image. Then we want our fish to be able to move, because this guy's going to move on its own rather where the player, we're moving it. And so we want to know how fast he's going to move, so we can do, you know, velocity. That's short for velocity. And then we can do, that's supposed to be an equals sign, move that way. Now let's go to the top and create those images that we're missing. So where I load my images, let's say we had bluefish equals pygame.image.load os.path.join assets fish eater, and it should be called bluefish.svg. And then I'm just going to copy and paste this two more times, because I have a yellow fish and I believe it was a green fish. And for me, green, yellow, and mine are all SVGs. Now we don't need to maintain ratio because the only one we were stretching out is the player. As he eats fish, he gets bigger. But we do still need to scale the images to the way we want them to look. So we'll start with bluefish equals pygame.transform.scale bluefish, and I will make him, this is the guy that you can eat at the beginning of the game, that's why he's going to be so small. And then greenfish, we could do pygame.transform.scale greenfish, and I'll make greenfish 200 by 200, and then last but not least, yellowfish, pygame.transform.scale yellow fish, and then my yellow fish is 175. You can always do your own numbers you'd like. You could even add more fish. You could add like a shark at some point if you want to. I'm just going to show you how to do the bare bone basic of the game. Alright, so at this point, we need to go back into our player fish. Well, actually, we can watch him move first. So when we go into the bottom, notice we created a list to hold all of the enemies we currently have on the screen and how many enemies should come in each wave. So like wavelength is 3, that means 3 fish per wave. So on our draw window, we're going to, we can do this real quick. We could do player start position. We could do player.x equals width divided by, this is to get him in the center. Player.y equals height divided by 2. So that's the screen size divided by 2 will give you the middle. Anyway, so when we go into our redraw window, I added a comment here so we can have a nice placeholder. For enemy in enemies, because that's our list, we say enemy.draw on the screen. Now if you notice, we didn't do draw on screen for the enemy because we already created one for the fish class, which is why it's very nice that we inherited these things. So don't have to code it several times over, it just inherits it. So now that we've drawn our enemies on the screen, we can go into our game loop, and right after we draw on the window, right here, we can spawn enemies. So if the length of our list, which is enemies, is 0, we can spawn more enemies. So for I in range of our wavelength, we'll say enemy equals enemy, that's my class name, and remember the parameters it takes. This is going to be our random range from 0 to height minus 100 because we don't want him to be off screen. Have some spelling errors there, my bad. And then we will say random.rand int from 0 to 2. And then we need to add it to the list or we'll never see it. Enemies.pend enemy. Oh boy, okay. Long program here. It's about 200 lines of code. I mean, give or take. It might be a little less. Alright, so now when we run our little program here, we can actually see the fish. They can't move yet, but we can see we got 3 fish. It went through the one wave because we didn't add more to the waves either. Because it said, hey, add a fish, add a fish, add a fish. For I in range of wavelength, which was 3, then it added it, and we never deleted from the list, so it doesn't run again, which is why there's only 3 right now. And again, they're not moving because we didn't call that .move function yet either. So what we want to do is after the player controls, we kind of want to add a little spot here where we can move our enemies, because that would be good, wouldn't it, if they could not sit there. So let's move our enemies. So for enemy in enemies, we're just going to iterate through our whole list of enemies. We'll say enemy.move. and it takes in a velocity, right? So we can make the speed random if we'd like. So some are faster than others. And we want to remove enemies from screen for every wave. And so we could also do simultaneously, actually. So for when the player collides with our, like, when the player collides with the enemy, we want to be able to make sure that he can, like, eat it or whatever. So what we're going to do is actually add another function to our class that checks if it's collided with or not. Or, well, we could add it to the class. Where do we... So if we go all the way to... Well, not all the way. If we scroll quite up to the top of our code, we can actually add a function that will check for collision. Alright, so sorry about the thing. I thought I messed up my code here. So if we go over here and we maybe go towards the top here where we created our functions, right? We can create if collide, or not if collide, we can create a collide function. So it'll take two objects, right? Let's check if you collided with you, right? So we'll say offset x equals object2's dot x's value minus object1's dot x value, right? Subtract the two x positions, see if it overlaps or not. You'll see where this is going. So offset y is actually going to be the same thing, but with the y values, because again, same math here. And then we can return object1 dot mask dot overlap. Oops, oh my goodness. Object2 dot mask, and then we say offset x, offset y is not none, because if it's not 0, right? So that is our lovely collide function. And now if we go back to where we were, where we're removing the enemies from the appended list here, we can actually save some time and just check if collide, right, because it returns a Boolean value, if enemy collides with player. Now we need to check if the fish is bigger than enemy fish. So if player dot get with is greater than enemy dot get with, we want to prevent the player from getting too large, because that would, you don't want like the whole size of the screen or anything. That's terrible. So I'm gonna cap it at 400. So then if that's the case, we want to increase player size, which we did not create, by the way, which we will do now. and we're only increasing it by about 0.1, of course. So player.increase size. Then we need to update the image because the original image was set to be scaled at a specific size all the way at the top that we did. So we have to make sure that our player image gets reset to the new size. So when it's drawn on the screen, it's the new size. And then enemies.remove enemy, right? Because it was like eaten or whatever. Now we can say enemy fish is larger than player. Wait, why is this not airing? Oh, it is. Okay, I was gonna say we did not make that yet. Okay, enemy fish is larger than player. We want to create our else statement, which corresponds to this right here, right? So if that is bigger, we will say if player dot fish image dot get width is greater than the player image, right? This is the ratio times 0.1, right? We want to decrease player size if possible. So decrease player size is also, we're going to make these at the same time. I thought it made sense just to do it all at once and then go back and make the two things that we need. So if we decrease the player size, again, we're doing this 0.1. Player.decrease size, we'll make that, we'll make the increase, and we still have to do the same thing by updating the image based on what I just said. It's the same thing, just the other way around, vice versa. So player image equals player dot fish image, and then enemies, we're still removing it from the list. And then, to be fairly honest, we could, if it's not this case, but it's, so if the fish is not bigger, but the fish is still not bigger than the bare minimum, then we lose. This would be game over. So lost equals true. So then we got if enemy dot x plus enemy dot get height is greater than the width of the screen, enemies dot remove enemy. Which I'm wondering if this needs to be here actually. There we go. And then, so now let's go back to our player class and create those two functions that we're missing. Player fish. So let's do increase size first. So we'll do definition, increase size. And we're going to pass in those two arguments or parameters. We're going to create those two parameters that would need to be done in there. So it was obviously like width and height, which is why we typed in 0.1. That's as much as we're going to increase it each iteration. Self dot width plus equals width times, to keep the ratio not disgusting, self dot height plus equals height times player image height. Then we want to say self dot fish image equals Pygame dot transform dot scale player image self dot width self dot height, and then self.mask, because we also got to keep the bounds for it so the collision still is, it makes sense with what the actual size is for the sprite. So Pygame dot, oh my gosh, dot mask from surface self dot fish image. And then we have to do the other way around, where we say decrease size, still width, still height. And we can just copy and paste this and just change the plus signs to minus signs. And that's essentially the same thing there. So what we've done is quite a lot, but if we run this, we should see our fish move, and now he gets bigger, and bigger, 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 and I could eat all my fish. I should not be able to get bigger than a certain point, which looks about right now. Yeah, see, he's not increasing anymore because that maximum cap of 400. Very nice. And otherwise you'd be getting the size of the, like, he gets so big you wouldn't really be able to move around at some point. So there you go. Oh, I guess we could yeah, that's about it. That's the entire game there. If you want to create a game over screen, I could show you that also. Otherwise the game's kind of done here. But so at the top here, I like to create a section. See how organized this is? You got comments, you got everything that's in that one spot. It's all organized. You can easily find where you need to go. Like, oh, where did I load those images? Right here. Let me add another one. Or, oh, let me change the It's all so organized. So organized. So fonts / messages. So you could say small font equals pygame dot font dot system font. Again, I'm just using like just some random font. This is gonna be the font size. Then we could say game over message. Oops, spelled message right. And then we call our font, and we want to render it. And I want to render it to say game over. Oops. And then we say true. And then we give it a color. I'm going to say red. And then we can have a second message to tell them to click to play again. Small font dot render. Click to play again. And then again, true and red. Don't know if it's case sensitive. Alright, so you could probably guess where we need to place this code at. But so go to your game. Yeah, see, it's gonna be about 200 lines of code. Just do this. So when we go down to our main game loop, right after we draw our enemies, there we go. So after we draw our enemies, so for enemy and enemies, right in the redraw window, we can check for game over. So after we placed our player on the screen, actually, not, it was right underneath. So check for game over. So if lost, remember that Boolean variable we created originally, we already set the values to be lost and stuff. Screen dot fill. I'm just gonna make the whole screen black. And then on the screen, I'm gonna add over the game over message, and the position on the screen is gonna be not, this isn't really centered, but at least it's on the screen. be like figuring that out. And then I want to put, I'm just, same thing again because I have two messages I'm putting on the screen. And I just want it underneath. So I'm going to divide the height by 4 because the Y position is the only thing that needs to be affected differently so they don't overlap on each other. Yep, there we go. And did I type it wrong? Oh, I have an extra set of parentheses for no reason. Don't know how that happened. Alright, so the game over screen works now if you were to run it. However, I think the click to play again part is oh wait, let me see. So we run this. Game over. Yeah, so the click to play again part we did not do. But you can tell that it does work. We can see our game over messages. And we go back to our code just to fix that. Where was it? Right, here we go. So if lost, and then after this right here, we say click to play again. So we say for events, and it should look familiar in pygame.event.get, and then we say if event.type equals pygame.quit, then quit, else, oh, actually not else, I don't know why I thought it was else, if event.type equals, nope, pygame.mouse button down, which clearly means that you clicked, we set lost back to false, meaning you didn't lose yet, which will automatically update in the game. Why is this? Oh, it doesn't know who it is, so we just have to quickly go here and say global lost, which will just tell you, hey, pass in this variable so we know who that is from the global scope. So now if we lose on purpose, we click to play again, and now we can play again. And that is the game. Try to go kind of fast to not be a super long video, but it is kind of a complicated game. About 200 lines of code. If you have suggestions for another video guide, whether it's Python, Java, JavaScript, Xcode, sorry, Swift is the programming language, but Xcode's environment, or literally anything I know most popular languages and environments in the modern day, please leave a comment below, and I'll catch you in the next video.